So here's basically how the aluminium ion then reacts with the hydroxide ions. Okay, so here's the, remember that this could just easily be written as Al3 plus aqueous. Okay, but here's what it is really like with the six waters. And because of the high positive charge and how small the aluminium ion is, it weakens the bonds in the waters, which means one of the oxygen-hydrogen bonds can break, which releases a proton or a hydrogen ion, which leaves you with that left over. And remember, we talked about the charge going down by 1. So that's what happens naturally, and it just sets that up as its own unique equilibria. The key thing here is that if I start to add hydroxide ions to this, the hydroxide ions react with the hydrogen ions from here, which then produce water, which, if you think about it, reduces the concentration of that, which means that equilibria shifts, and it keeps shifting and keeps shifting and keeps shifting until one of all of the waters has lost all of their hydrogens. So we're left with 5 waters, and that 6th water, because we've added hydroxide ions, has gradually removed the hydrogen ions from here to form water over there. So that has gone to there by picking up a proton from the water. Let me just go over that again. Just get rid of these bits here. So as I add hydroxide here, it reacts with one of the hydrogens in one of the waters. The equilibria, this equilibria here, shifts that way, which means we get to a point, if we keep adding hydroxide ions, that all of the hydrogens off one of the waters is removed. So the hydroxide here has formed that by removing a hydrogen from one of the 6 waters here, which leaves you with 5 waters left and 1 hydroxide, and the charge goes down by 1. And of course that can happen a second time. So if I continue to add hydroxide ions to this, which starts my second stage up down there, you can see that another one of my waters here will donate its hydrogens to that hydroxide to form another water. So one of the waters there has now been removed, and we've made another hydroxide there. Okay, and then as we continue to add the hydroxides here, that equilibrium keeps shifting all the way over to there until I've only got this, and then that can happen again. So I add hydroxide, it removes another hydrogen from one of the remaining waters. So the number of waters goes down there to 3, and the number of hydroxides, look, goes up there to there. Okay, so I'm going to try and show that in a bit more detail on something else. So essentially what we've got is we've got aluminium 3 plus in the centre here, and then I've got my 6 waters which I'm putting on, which are displayed. And of course this whole thing, and I've put the 3 plus in the middle there, I shouldn't really, because we put the charge on the outside. So the 3 plus charge is up there like that. Let me try that again, that's not really written there very well. So the 3 plus charge will be up here like that. So here's basically what happens. So as we add hydroxides onto this, so there's a hydroxide, that hydroxide removes a hydrogen from there, which means this is going to form water. So let me remove all of that. So that's going to form water down. That's going to form water. And what I'm left with now is 1, 5 waters and 1 hydroxide, which is that bit there. Now, if I continue to add hydroxides, basically what happens is one of the waters, so it's the one that was that water there, all of those in all of the aluminium aqueous ions will lose their 1 hydrogen until there are no more left with 6 waters. When we get to that stage, if I continue to add hydroxide ions, it then takes a hydrogen ion from one of the other waters. So that forms water, so that would be another water. So it forms water. Let me just rub that out. Okay. And of course, what I'm left with now is 4 waters, and now 1, 2 hydroxides. And of course, each time I have a hydroxide, the charge goes down from 3 plus to 2 plus, and then with 2 hydroxides, that becomes a 1 plus. And then if I continue adding hydroxides to this, so if I add another hydroxide on there like that, that will remove another hydrogen from another one of the waters. So that will form water again. And this time I've now got 3 waters and 3 hydroxides. Now remember, the aluminium had a 3 plus charge, and each of the hydroxides has a 1 minus charge, and I basically got 3 of them. So the 3 1 minuses now cancel out that, which means the overall charge is neutral. It has no charge, and the moment it has no charge, it is now not soluble. Which, if I clear all this mess up here, so these are the stages that I've just gone through. Because it has no charge, it can't be surrounded by any of the waters. Basically, if it hasn't got a charge, it is insoluble. So what we get now is this. We get this white precipitate of aluminium hydroxide, which we often write it as AlOH3. But what it really looks like is this here. Okay? So we can write it out like I've kind of done here. But we could simplify it to these reactions that we've got down here. So 1 hydroxide removes 1 of the hydrogens from one of the waters. I have 5 waters left, 1 hydroxide, and the charge goes down. Once all of these run out, I'm then left with this, which, if I continue adding hydroxides, it then removes a hydrogen from one of the remaining waters, which will leave me with 4 waters. I've got 1 extra hydroxide, which reduces the charge again. As I keep adding the hydroxides, I eventually run out of this, and I have only this, which, if I continue adding the hydroxides, it will then react with another one of the waters, leaving me with 3 waters left, 3 hydroxides. At this point it is neutral, and because it is neutral, it is insoluble. And aluminium, not being a transition metal, will give you a white precipitate. Again, this can be simplified further again by doing it all in one stage. So we could do it in one stage where we've got that. So we've got 1 mole of that with 3 moles of hydroxides. So the first mole of hydroxides will remove 1 hydrogen from one of the waters. The second mole of hydroxide will remove a hydrogen from the second lot of waters. And the third mole of hydroxide will remove the hydrogens from a third water, which gives you this, which is our precipitate, which is white. And again, if we remove the waters and look at it in its other format, we could have it where it looks like that there. Okay, and if you remember that, this bit here, so these two bits here, that's one in the same. If you remember what we did up here, look, that, and that are one in the same. Okay, so that's why this aluminium, we call it a hexa aqua iron because it's got 6 waters. That's why this dissolved aluminium 3+ ion is slightly acidic, and because it's acidic, it will react with hydroxides. How many hydroxides will it react with? Well, it will react with as many in order to remove the charge completely and make it neutral. At that point, it becomes a white precipitate. And I think that's a good point to stop that one there.